Here is a productivity example that is a little more complicated than what is in the course pack, and you may get homework or exam problems that are similar to this. In this example, I'll just read the text box here. Etched Impressions produces custom laser etched artwork on a variety of flat wood surfaces. Last month, they produced 930 units from the following inputs: 300 hours of labor, 1,000 linear feet of wood, and 2,260 BTUs of energy. After making some capital improvements, this month they were able to produce 1,080 units from the following inputs: 275 hours of labor, 880 linear feet of wood, and 2,600 BTUs of energy. Additionally, assume the following price and cost information. Average sales price is $22 a unit. Labor costs are $12.25 per hour. Wood costs 96 cents per linear foot, and energy costs 48 cents per BTU. Now, if we look at the way we could compute productivity, we could do it a number of ways. So again, it's important to read the questions carefully, and when you're in the workplace, understand what you're measuring and making sure you get the right inputs and outputs for those measurements. In this case, if we wanted to measure the productivity in terms of units per labor hour of input, that would simply be taking the units of output, the finished product, 930, and dividing that by the labor hours in. Now, if we wanted to figure out what the revenue per labor hour of input is, then it gets a little more complicated. We would have our output in terms of dollars. We would need to multiply the finished product units times the average sales price in our numerator. So we'll take the finished product's output times the average selling price, and then we will divide that by our total hours of labor input times the cost of that labor per hour, per unit of input. And so in this case, this tells us that for every dollar of we put into labor, we get $5.57 of revenue. Now, we could do the same for the linear feet of wood or BTUs, and we'd have similar results. But these measurements here are in terms of units. So for every unit of wood, we get 0.93 units of output. For every unit of energy, BTU, we get 0.41 finished products. Now, the multi-factor productivity is a little more complicated because since our inputs are different units of measure, we have labor hours, wood, linear feet, energy, BTUs, each of those is different. We must normalize these to one unit of measure, and we're going to use the dollar for this. We also have to change our output from units produced to revenue or dollars worth produced. And so in this example here, when we do the multi-factor productivity, it tells us for every dollar of input combined among labor, wood, and BTUs, we get $3.58 of output. The equation's a little complicated, but you can see here in the numerator D8, which is our units output, times D2, the cost or the price, the average sales price per unit. That would give us our revenue, the value of the output, and then the value of the inputs, we divide that into the outputs, D9, which gives us our labor units, times D3, our labor cost per hour, and D10 times D4 to get us our wood cost, plus D11 times D5, which gives us our cost of energy. And that gives us, again, our multi-factor productivity. So again, you might have a number of different scenarios and different given data. Just have to read carefully what the question is asking for and make sure you are responding appropriately.